So in number 11, we have a spherical hollow inside of a lead solid sphere of radius 4 centimeters. The surface of the hollow sphere passes through the center of the sphere and touches the right side of the cylinder. The mass of the cylinder before hollowing it out was 2.95. With what gravitational force does a hollow-out lead sphere attract a small sphere that lies a distance of 9 centimeters from the center of the lead sphere, on a straight line connecting the spheres of the hollow? If you initially look at this, you're like, oh my goodness, I'm going to have to integrate each little piece of mass of the remaining lead sphere to figure out the net force on this. But there's a powerful idea in physics called the law of superposition. What we can actually do is this. We can figure out that the total force is going to be the force due to the entire sphere before the hole was drilled out, minus whatever force was due to whatever this little sphere was. Now the sphere is centered right here. The radius here is 4, so the radius of each one, or this one's going to be 2. Just to sort of visualize this before we get started. So now we can actually plug in some numbers. To figure out the total force due to the sphere before the hole was in, it would just be g times the mass of the entire sphere times the small m mass over r squared minus the missing force due to that hole. And the only tricky part is we got to figure out what the mass of that material that was removed was. To do that, it might seem logical that the mass of the hole should be equal to the volume of the hole over the volume of the entire sphere, that ratio times the entire initial mass. And that turns out to be true. Plugging in our numbers, remember again the radius of our small hole is 2 centimeters. The radius of the entire sphere is 4 centimeters. We can simply take that times the total mass, and we'll discover that the mass of our missing hole is 1/8 of the original mass, or 1/8 of the 2.95 kilograms we were given, which ends up being about 0.369 kilograms. We can now plug that into our equation down below. So we're actually going to take the entire mass of the sphere before the hole was drilled out. Why? We're going to pretend as if that hole wasn't there, and then we're just going to subtract the missing force because of this missing matter. The mass is this right here. This is our mass of our missing hole from up above here. And you might say, wait a second, why is this 0.07? Well, the distance from the center of missing mass of our hole is 7 centimeters away from this because of the radius of our hole. So plugging that in, if you solve those two, you'll get this much force for each one of those. Subtracting those gives us our net force, about 8.31 times 10 to the minus 9th newtons. Hopefully this makes sense. It's a little bit unusual. The law of superposition, though, is incredibly powerful. Good luck.